company motto is, where space exploration drives innovation. For Mission 2, we called our rover TORO 2, and TORO stands for Terrestrial Object Retriever and Observer. Our rover was programmed for interruptible continuous motion, and our rover design had high obstacle clearance and ease of maneuverability, which helps us to navigate objects more effectively. Expenses. Our goal here was to stay within budget without compromising the achievability of our rescue mission. We were under budget on our Mission 1, but we did go over budget during Mission 2. Navigation. Our rover design was for interruptible forward motion and automated retrieval. The capabilities of our rover included a push button for claw activation, moon buggy retrieval, a light sensor for remote directional control via laser. And our rover was programmed for continuous forward movement loop broken by light sensor. Here's Jay.
All right, how many of you have ever been in construction before? Raise your hand, don't be shy. All right, well, as you know, in construction, it's really hard to move rocks around a little bit and stuff like that. If you don't move the tractor right, you can actually flip the tractor over and stuff like that. Well, on our TORO 2, we tried to make sure that our rover wouldn't flip over. We were more interested in our integrity and structure and stuff like that. We had TORO 1, which was very good for pushing the rocks. However, we had some problems with it because we did not have any sensors to navigate it. So even though it was on a one-way trip most of the time, it would sometimes get stuck. Even a little pebble would make it stop rolling, or sometimes it would be going around the surface of the rock would get on its side, changing it from its axis of rotation. But we fixed all those problems with TORO 2. We put a sensor on it. It's a light sensor, excuse me. And what we did was we pointed a laser at it, so that every time the laser would be pointing at it, it would stop, reverse for a bit, and then it would turn about 45 to 60 degrees, depending on what kind of terrain it is on the time. Now, one of the interesting things we had on our TOROs was its maneuverability, and this is something I'm really proud of. Even from the TORO 1 design, we started with concerns, how do we make this robot turn? Well, what we did was we made the twin engines. We put one engine on each of the two wheels in the front, and there were big wheels, and the engines were independent of each other. So basically, one could go forward, one could go backward independently. And that created us to be able to turn without any displacement in its position. And this was highly effective. We put swiveling wheels on the back of the rover. This is one of the pictures during the development of, I believe, TORO 2. And it worked very well. The swiveling, it was not disappointing at all. The TORO can literally rotate, it can move, it can go backward, forward, it can move in any single way you want it. It was very compact, it was very rigid, very reliable. It did not disappoint at all. And the structural integrity was actually pretty impressive. Now on our budget, we did have a lot of findings on our first TORO, but again, the problem we noticed was navigation. We had a lot of navigation problems, and the rover was easily stuck. So we fixed that by adding a light sensor, as I said previously, on the new TORO 2 design. And when we tested this, we actually got a plus out of it. So for the first TORO 1, we didn't get any wrong. But for our Mission 2, we actually got about 3 buggies out of it. We almost got a 4th. In fact, we were so good at it that we actually got our rover all the way to the other team's side and infiltrated their space. And we almost stole one of their buggies too. So that was highly impressive. So considering that we had a lot of loss in the first TORO, our improvements in the second one more than made up for it. Even though we still were facing a negative $280 million, we believe in the future we're going to continue lowering those costs, and we're going to continue making them effective. And those are our lessons, you know, we really have to focus on our teamwork. I mean, communication is very important. If no one's on the same page and everyone goes off and start doing different types of designs, different things, none of it's going to fit with each other. And so we needed everybody to make it so that everything fit with each other. And, you know, we had, of course, a lot of obstacles, because some of the rocks were pretty difficult to push. So we made it so that the rovers would avoid it, just reverse, and then turn around. There was no problem at all. And I'd like to thank our entire team, because our entire team worked very hard on it. We worked almost every minute on it. You know, we had our CEO, Anna Marquez, our project engineer was Aaron Looper, we had a procurement manager, Jeremiah Muster. I'd like to thank Jason Williams, Gabriel Jesus, Heather Monroe, system managers. Our programmers, Joshua McVeigh, Aaron Looper, these two programmers, if it were not for them, we'd be dead in the water. We wouldn't have anything. So I want to especially congratulate those two programmers. Our engineer design team, I was actually part of it. Jason and you see my name up there. We also had Jason Williams, J.W. Balch, Jose Granado, Gabriel Jesus, Heather Monroe, also working on it. And for purple, we had Jason McCandless, Jennifer Cadron, Francis Washington, presentation. Francis Washington, me, and Jennifer Cadron. And this is Orange Robotics, where space exploration drives innovation.